Let's practice applying our exponent properties involving the power of powers property. Real quick before we get started, if you'd like a free copy of this blank PDF as well as the annotated answer key PDF, you can find a link to that in the description box below. Also, if you'd like to try any of these problems on your own, feel free to pause the video whenever you need to think a little bit and give it a try yourself, and then we can go over it together once you're ready to move forward. Let's jump right into it. For number one, we have the quantity of x cubed times y to the fourth power, and the whole thing is going to be squared. Right away, you do want to notice that we have two bases here. We have x and y as our two bases. So when we go ahead and write this, the little 2 on the outside means that we're going to have this x to the third power. This is going to be raised to the second power. So when you have these, you can just multiply the 3 and 2 together. That's the power of a power property. And then we're going to go ahead and multiply this by y to the fourth power, but that's being raised to the second power. So you can go ahead and multiply those exponents as well. Now if we go ahead and multiply these powers over here to the left, that 3 times 2 for those exponents, that's going to be x to the sixth power, and then this 4 times 2 for the exponents for the y, that's going to be y to the eighth power. So our final simplified version here is going to be x to the sixth power times y to the eighth power, and we can write this a little bit simpler like that. For number 2, we have this quantity of a to the fifth power times b to the second power, and that whole thing is raised to the second power. So there's 2 of both of those bases. So again, we have two bases, a and b, so we have this a to the fifth power, but we do have 2 of those being multiplied by each other, so it's a to the fifth times a to the fifth, or we can use that power of a power property and multiply those exponents. And then we have this b to the second power, but that has to be raised to the second power as well, so we're going to go ahead and multiply those exponents together using that power of a power property. Now first, this a to the 5 times 2 power, 5 times 2 is 10, so we can go ahead and just write a to the 10th power, and then this 2 times 2 over here, that's going to be 4, so that's going to be times b to the fourth power. So that would be using that power of a power property. For number 3, we have this quantity of x to the fourth power times y to the seventh power, all raised to the second power. Notice we have 2 bases here, just like in the prior 2 examples. So first we have this x to the fourth power, but it's being raised to the second power, so we can multiply those 2 exponents together. And then we have this y to the seventh power. Go ahead and write y to the seventh, and that's being raised to the second power, which we can just say we're going to multiply that by 2. Multiply those little exponents together. Now for the x, this 4 times 2 is going to be 8, so that's going to be x to the 8th power. And now for the y's, if we multiply those 2 powers together, exponents rather, we're going to have y to the 14th power. So that would be our equivalent expression. Here's number 4. For number 4, we have the quantity of 5 times a to the third power times b to the fourth power, all raised to the second power. Not only do we have our base of a and b, but keep in mind that a coefficient or a normal number in front multiplying is also going to be a base. So everything inside this parentheses is going to be raised to the second power. So first we're going to have 5, and that's going to be raised to the second power. And then we're going to have this a to the third power, or a cubed inside. That's going to be raised to the second power as well. And then this b that we have inside, that is b to the fourth power originally, but that's being raised to the second power. So we're going to go ahead and multiply those exponents together. Now, if we go ahead and go a little bit further here, now we're going to start with this 5 squared. So 5 squared, that's going to be 25. That's what we're going to write as our new coefficient. Then using the power of power property, 3 times 2 is going to be 6. So that's going to be times a to the sixth power. And then this 4 times 2 is going to be 8. So it's going to be times b to the 8th power. So this would be our equivalent expression. In number 5, we have the quantity of 3 times x to the 7th power times y to the 4th power, and that whole thing is raised to the second power. Notice again, just like in the last example, we have 3 different bases here. So our first base is going to be 3. So again, this is 3 to the first power. I'm just not writing the little 1. So 1 times 2 would just be 2. So hopefully that's okay that I'm just going right to writing that 2, just because it has a little invisible 1. And then we have this x to the 7th power. I'm going to go ahead and write x to the 7th power, but that is raised to the second power, or multiplying those powers together. And then third, we have a third base of y, that's to the 4th power, but that's being raised to the second power. So we're going to go ahead and multiply. All right, now let's go ahead and simplify this some more. So 3 squared, that's going to be 9. That's going to be our new coefficient here. And then 7 times 2 for the exponents is 14. So we're going to have times x to the 14th power. And then we have 4 times 2, and that's going to be 8. So that's going to be times y to the 8th power. So that's going to be our simplified expression. In number 6, we have the quantity of 4 times a squared times b to the 9th power, all squared. First, we have 4 to the first power raised to the second power, so 1 times 2. Again, I'm using a little shortcut and just writing 4 squared. Hopefully that's not too confusing. And then we have a squared on the inside, and that's being raised to the second power, so we're going to multiply the exponents together. And then we're going to multiply this whole thing by b to the 9th power, and that's being raised to the second power, so 9 times 2. Okay, so these are going to be our three bases here. First, we have this 4 squared, or 4 to the second power. 4 times 4, that's going to be 16. And then for the a, their exponents, 2 times 2 is 4, so it's going to be times a to the 4th power. And then for b's exponents, we have 9 times 2, which is 18. So it's going to be b to the 18th power. So that would be our simplified expression. For number 7, we have negative 3 times x to the negative 6th power times b to the 4th power, all being squared. So we have three bases here. Now our three bases here are negative 3, x, and b here, okay? So let's go ahead and see, this is starting off with a negative 3. Now put that in parentheses because it's negative, and that's going to be raised to the second power. That's going to write first here. And then we're going to have an x, right? And this is going to be x to the negative 6th power. So this one's a little different just because we have a negative exponent, but we're going to apply the same rules here, okay? And then finally we have b raised to the 4th power, and that's going to be raised to the second power. So it's 4 times 2. Okay, so let's go ahead and multiply our negatives here. So a negative 3 times negative 3, that's going to be a positive 9 for our coefficient. Then for our x exponents, that's going to be negative 6 times 2, that's negative 12. So that's going to be x raised to the negative 12th power. Okay, we'll talk about negative exponents maybe in another video. And for b, we have 4 times 2, which is 8. So that's going to be b to the positive 8th power. So this would be an equivalent expression just like that. Here's number 8. For number 8, we have this expression, the quantity of negative 7 times a to the 6th times b to the negative 5th, all raised to the second power. Just like the last couple examples, we have three different bases here. Our first one's going to be negative, so make sure you go ahead and say this is going to be a negative 7. We're going to raise that to the second power because that's the exponent on the outside of the parentheses. Then we're going to go ahead and multiply this by a to the 6th power, but we're raising that to the second power, so we'll use that power of power property. And then we're going to go ahead and say that we have a b, and that's raised to the negative 5th power, but we're going to go ahead and square that. So let's use multiplication and multiply those exponents together. Okay, so first things first, negative 7 times negative 7 is going to be positive 49. And then for the exponents for a, 6 times 2 is 12, so we're going to have a to the 12th power. And then for b, we have negative 5 times 2, which is negative 10. So that is going to be times b to the negative 10th power. Okay, so of course you can rewrite these using only positive exponents, but we're going to save that for another time. Here's number 9. For number 9, looks like we're back to two different bases. We have the quantity of x to the 7th power times y to the 4th power, all raised to the 3rd power. Our two bases here are going to be x and y. First, we're going to go ahead and write that we have x to the 7th power, but remember we have 3 of these, we're going to multiply by 3. And then we're going to have this y to the 4th power, but keep in mind that we have 3 of these, so we got to multiply that by 3 as our shortcut using the power of a power property. Now let's go ahead and say, what's this going to be? Well, for the x's exponent, 7 times 3 is 21, so we're going to say it's going to be x to the 21st power. And then for y's exponents, 4 times 3 is 12, so that's going to be times y to the 12th power. For number 10, we have the quantity of a to the negative 4th power times b to the 6th power, all raised to the 3rd power. Our two bases here are going to be a and b, so first we're going to have a to the negative 4th power, that's raised to the 3rd power. We're going to say we have 3 of those, so multiply those exponents together. And we're going to multiply this by b, and that's raised to the 6th power. But we have 3 of these, so we're going to multiply 6 times 3 together there. All right. Now for the a's exponents, negative 4 times 3, that's negative 12, so that's going to be a to the negative 12th power. And then for b, we have 6 times 3, that's going to be 18, so it's going to be times b to the 18th power. So that would be our simplified expression. For number 11, we have the quantity of this x to the 7th power times y to the negative 5th power, all raised to the 3rd power. Our two bases here are x and y, so first we have this x to the 7th power, but we have 3 of them, so our shortcut is going to be multiplying these together using that power of a power property. Then we have y to the negative 5th power, but we have 3 of these, so we're going to go ahead and multiply that negative 5 times 3. So first, multiplying 7 times 3, that's going to be 21, so our simplified exponent here is going to be x to the 21st power. And then over here we have negative 5 times 3, which is negative 15. So it's going to be times y to the negative 15th power. So this would be an equivalent expression. For number 12, we have the quantity of a to the negative 3 times b to the 9th power, all raised to the 3rd power. We have our two bases of a and b here, so we're going to apply that little 3 on the outside to both of those. So first we have a to the negative third power from the inside, but we have 3 of those. We're going to multiply that times 3. Then we're going to go ahead and multiply this by, let's say, b to the 9th power is what we have inside, but we have 3 of those from that little 3 on the outside. Now for the a's, if we multiply this negative 3 times 3, that's negative 9. So we're going to have a to the negative 9th power. And then for b, we have 9 times 3, which is 27. So it's going to be times b to the 27th power. So that's as simplified as we can write this without using any fraction bars, even though we have negative exponents. Here's number 13. For number 13, we have the quantity of 2 times x to the 4th power times y to the 7th power, all raised to the 3rd power. So we have 3 bases. We have 2, x, and y. So first we have 2 to the 1st power, and that little 1 times a 3, that invisible 1 times 3 is just going to be 3, so that's why I'm not writing the 1. And then what we're going to do next is we have this x to the 4th power, and we have 3 of those, so we're going to multiply 4 times 3. And then for our y's, we're going to have this y to the 7th power from inside, and we have 3 of those, so we have 7 times 3. Okay, so let's put this all together. This 2 to the 3rd power, that's 2 times 2 times 2, that's going to equal 8. And then multiplying these two exponents, 4 times 3 is 12, so it's going to be times x to the 12th power. And then for y's exponent, 7 times 3 is 21, so we're going to have times y to the 21st power. For number 14, we have the quantity of 3 times a to the 3rd power times b to the negative 1st power, all raised to the 3rd power. Now we have 3 different bases over here, so let's apply that little 3 on the outside to all 3 of these bases. So first we have 3 to the 1st power. That little 1 times a 3 is going to be just 3, so we have 3 cubed. And then we have this a to the 3rd power inside, a to the 3rd power, and there's 3 of those, so we're going to multiply by 3, those little exponents together. And then finally we have b to the negative 1st power, but we have 3 of those, so we're going to multiply those exponents of negative 1 and 3 using that product of powers property. Putting these all together, 3 to the 3rd power is 3 times 3 times 3, which is 27. So I'm going to write 27 here. Then for a's exponents, using that power of a power property, 3 times 3 is going to be 9, so that's going to be times a to the 9th power. And then for b, we have negative 1 times 3, which is negative 3. So we're going to say times b to the negative 3rd power. For number 15, we have the quantity of 2 times x to the negative 3rd power times y to the 2nd power, all raised to the 4th power this time, so a slightly higher exponent. Again, we have 3 different bases here. Our first base here is going to be 2. So this 2 to the 1st power raised to the 4th power, 1 times 4 is just going to be 4, so it's 2 to the 4th power. And then we're going to multiply this by, this is going to be x to the negative 3rd power raised to the 4th power, so negative 3 times 4. And then finally for our third base, we have y to the 2nd power originally inside. Then just multiply the little exponent by a little 4, just because we're applying that power of a power property. Okay, so combining this all together, first we have this 2 to the 4th power, that's 2 times 2 times 2 times 2, that's going to be 16. And then for the x's exponents, negative 3 times 4 is negative 12, so we have times x to the negative 12th power. And then for y's exponents, we have 2 times 4 is 8, so it's going to be times y to the 8th power. So this would be the most simplified version. Finally, for number 16, we have the quantity of negative 3 times a to the 4th power times b to the 5th power, all raised to the 4th power. So what we're going to do here is notice that we have 3 bases, and here they are. Now keep in mind our first base is going to be this negative 3, so we should go ahead and put that in parentheses. So it's negative 3 to the 1st power raised to the 4th power. 1 times 4 is just 4, so again I'm not writing that little 1 there. Let's go ahead and multiply this by this a to the 4th power, but that's being raised to the 4th power, so we have 4 times 4, use that power of a power property. And then finally we have this b to the 5th power, and then we have 4 of those, so it's going to be 5 times 4, use that power of a power property again. Now let's go ahead and combine this all together by using some multiplication and simplifying this all together. So negative 3 to the 4th power, that's going to be negative 3 times negative 3 times negative 3 times negative 3. That's just going to be equal to positive 81. And then for a's exponents, 4 times 4 is 16, so that's going to be times a to the 16th power. And then for b, we have 5 times 4 is going to be 20, so this is going to be times b to the 20th power. So there you have 16 different practice problems. Whenever we had any with coefficients, just keep in mind all the coefficients technically have a little invisible exponent of 1. So 1 times whatever the exponent on the outside is just going to stay the same. So I just wasn't writing it, but if you can, if you want to write it, feel free to go ahead and do so. If you found this video helpful, please consider giving it a like and share with a friend or classmate that might find it helpful too. And as always, keep up the great work that you're already doing, and I'll see you in the next one.